Today we will be reading about electric current, electric potential, both of these definitions with their formulas. In the previous lecture of electricity, we have already learned what is electric current and what is potential difference. Here we will do some illustrations based on the basic formulas and their definitions, right? Now, we have learned about charge. Now we are reading electric current. The rate of flow of charge through a conductor is called as electric current. It is denoted by capital I and its unit is एम्पेयर. कितना चार्ज यानी कि चार्ज होता है Q पर यूनिट टाइम यानी कि एक सेकेंड में कितना चार्ज फ्लो हो रहा है, दैट इज इलेक्ट्रिक करंट. So if this unit is ampere, which is indicated by capital A, Q is having a unit of coulomb, which is denoted by C, and time is having a unit of seconds, which is indicated by S. So ampere is coulomb per seconds. So we can write it as this also. Now, what is the direction of electric current? Electric current I always flows in opposite direction of electrons. If electrons are moving from left to right, the electric current will move from right to left. Okay? If electrons are moving in this direction, the current will move in this direction. Is it okay? I, that is current, always flows from high potential end to the lower potential end of external supply. Means external supply can be your cell, can be your battery, can be your power supply. So it always moves from higher potential end to the lower potential end. Firstly, we need to read about some symbols so that we can understand. This is a symbol for a cell. The longer one, the longer end is a positive potential end, and the shorter end of the cell is called as negative potential end. So higher potential is positive potential and negative potential is lower potential end. This is higher, high potential, and this is low potential end. So current will move from high potential to the lower potential. That is, in this direction the current will flow. Now, then if cells are joined in series, this total combination is termed as battery. Combination of cells in series is called as battery. That is, several cells when joined together gives the term called as battery. There are generally two types of power supplies. One is AC power supply, which has the symbol, this is AC supply, and one is DC supply, which has this symbol. So this is DC supply. Okay, this is the symbol of a bulb. This is a symbol of resistor. This is the symbol of variable resistor. This will be the symbol of rheostat. This is the symbol of ammeter. This is the symbol of voltmeter. This is a symbol of a switch or a key. Okay, so these are generally the symbols that we will come across in our circuit when we will be doing some numericals. Correct? I hope this is clear. Note this down. This will be the positive end, the higher end. This is negative, this is positive, negative, positive, negative. Okay? Note them out. This is the symbol for a bulb. This is the symbol of a wire joint, and this can be the symbol for wire, two wires crossing with each other over one another without a joint, that is, they are not touching each other. Okay, so these are the basic symbols that we have to use. Now, let us do one question on this formula. Before that, we will be defining, there is a question called define 1 ampere of current. 1 ampere of electric current. How will you define it? As we know, current is Q by T. Q is coulomb, this is ampere, this is second. So when 1 coulomb of charge flows from one end of a conductor to the other end in 1 second by applying an external electric field to the ends of conductor. It is said to constitute a current of 1 ampere. Means अगर किसी कंडक्टर पे आपने कोई एक्सटर्नल सप्लाई लगाई तो उस एक्सटर्नल सप्लाई के पॉजिटिव एंड से यहाँ पॉजिटिव पोटेंशियल क्रिएट होगा और यहाँ नेगेटिव. So an electric field will be set up from positive to negative in the external side of the conductor. That means the conductor will be under the influence of an external electric field. So all the free electrons will also be under the influence of this external field only, and they will move from, the current will move from higher potential to lower potential, and the electrons will move from lower potential to higher potential, because electrons always move in the opposite direction of current, or you can say current moves in the opposite direction of electrons. So these are negatively charged, they will be attracted towards the positive, that is higher potential. So when the electrons move towards the positive potential, the current will move from positive to negative potential. And when this complete set of electrons makes 1 coulomb charge in 1 second, then we can say the total current is 1 ampere. मतलब अगर 1 सेकंड में 1 कूलम चार्ज यानी कि इलेक्ट्रॉन्स 1 सेकंड में 1 कूलम इलेक्ट्रॉन्स अगर नेगेटिव साइड ऑफ द कंडक्टर से पॉजिटिव साइड, दैट इज पॉजिटिव पोटेंशियल एंड ऑफ द इलेक्ट्रिक फील्ड की तरफ, कंडक्टर की तरफ आ जाए 1 सेकंड में, तब जो करंट बनेगा दैट विल बी 1 ampere. Now, the question is, how many electrons, or you can say charge, constitute 1 coulomb of charge? So see, charge Q is number of electrons into charge on one electron, that is Ne, when we are considering it as a free zone, right? Q is Ne. This is the charge and this is the number of electrons that are per unit volume of a conductor. यानी कि 1 मीटर क्यूब वॉल्यूम पे की कंडक्टर के 1 मीटर क्यूब वॉल्यूम पे कितने इलेक्ट्रॉन्स हैं, that is the number n, right? So n is number of electrons per unit volume of conductor. It can also be defined by the name as charge carrier density, or it can also be written as number density of charge carriers. Okay, so these can be the terms that can be given in the questions. So the total charge is 1 coulomb. This is n that you have to find into electron has 1.6 into 10 to the minus 19 coulomb of charge. So when we'll divide n by 1.6, 1 by 1.6 into 10 to the minus 19 coulomb. So your n will be 10 raised to power 10 into 10 raised to power 18 divided by 1.6. So you can write 100 into 10 raised to power 18 divided by 16, which can be 25 by 4, which in turn will be 6, that is 24.25 into 10 raised to power 18 electrons. That means your 1 coulomb charge consists of 6.25 into 10 raised to power 18 number of electrons traveling. Now, let us suppose the question is of the form if 150 coulomb of charge flows through a conductor in a minute, calculate the current. Now see here, you have to find out the current, and current is Q by T, and Q, that is charge, is in coulomb, and coulomb is given to you 150. That means Q is 150 divided by time is in seconds while it is given minute. So 1 minute constitutes of 60 seconds. So your current becomes 3532 and this becomes 2.5 amperes of current. Correct? This is one question. Now, if 2.5 ampere current flows through a conductor in 1 minute, find the number density of electrons through the conductor. That is, you have to find M, that is the number of electrons. So current was Q by T and Q can be written as NE by T. So I is given in amperes, there is I. So I becomes 2.5 is equals to N, we don't know. E, we are knowing 1.6 into 10 to the minus 19 divided by T is 1 minute, that is 60 seconds. Okay, make sure that you always have the right knowledge of the unit. If you have the correct knowledge of the unit, that to which symbol does it belongs to or to which quantity it belongs to, you will directly put the values and you will get the answer. Now you can see here that we can solve it by multiplying. So 2.5 into 60 divided by 1.6 into 10 raised to minus 19, that will be your n. If you can see, we can cut this down, and n will be 25 into 60 into 10 raised to power plus 19 will go up, and this will be 16. So now it can be written as, you can collect it from here like 2, 8, 16, 230 and 215, 2, 4. Now it can be written as, suppose 25 into 15, or we can say in the other manner also 25 into 15 into, let it be 10 raised to power 17 and 100 will be left here. So 100 divided by 4 becomes 25. So now this becomes 625 into 15 into 10 raised to power number 17. So this will be 15 into 5 is 75, 30 and 37, and 15, 6 is 90 and 93. This will be this much number of electrons. So in standard form you can say 9.375 into 10 raised to power 20 electrons per unit volume, that is per meter cube of your conductor, will flow if this much amount of current is needed to be flown through the conductor in 1 minute. Okay, so main formula you have to learn this. Understood? Now, proceeding ahead, we also in the previous lecture has discussed about potential and potential difference. So, what do you mean by the term electric potential? The amount of work done, and work done is equals to the energy spent. The amount of work done or energy spent in carrying a unit positive charge from infinite to a point in an electric field is called as electric potential. The meaning of this I have explained with an analogy of water pump system in the previous lecture, so you can understand the meaning of electric potential and potential difference from those lectures. Now, electric potential, it is denoted by capital V and its unit is volts. The formula is V equals to W by Q. W is work done, that is amount of energy spent, correct? And this is the charge that you are carrying. Again, there is a term called electric potential difference. Now, the amount of work done, that is energy spent in carrying a unit positive charge from one point to another point in an electric field is called as electric potential difference. It is denoted by V. AB means between those 2 points A and B. Let us suppose you are writing in carrying from one point A to another point B. So it will be VAB, and its unit is it can be, if points are not mentioned, then it can be written as V also, right? And its unit is volts. Again, the formula will be V of A minus V of B is equals to work done from A to B divided by Q. That is the work done of the energy spent divided by charge in the for which you have done the work. Now, what is the basic differences? अगर आप किसी अननोन पॉइंट से किसी नोन पॉइंट में, किसी इलेक्ट्रिक फील्ड के किसी अननोन पॉइंट से नोन पॉइंट में आप अपने चार्ज को लेकर आ रहे हैं, तो उसके अंदर जो एनर्जी स्पेंड हुई है दैट विल कंस्टिट्यूट अ इलेक्ट्रिक पोटेंशियल। और अगर आप किसी नोन पॉइंट से दूसरे नोन पॉइंट इलेक्ट्रिक फील्ड के अंदर चार्ज को लेकर जा रहे हैं, तो जो एनर्जी स्पेंड हुई है दैट विल बी इलेक्ट्रिक पोटेंशियल डिफरेंस। मतलब ये है कि जब आप बोलते हैं कि आप सेल लाए हैं 12 वोल्ट्स का, सो दैट सेल ऑफ 12 वोल्ट्स मींस देयर इज अ 12 joule of energy will be spent in carrying 1 coulomb charge from positive end to the negative end of that cell। कहने का मतलब ये है कि अगर आप बोल रहे हैं ये प्लस और माइनस और 12 वोल्ट की सेल है, तो ये 12 वोल्ट का मतलब है इन दोनों इलेक्ट्रॉन्स के बीच में जो पोटेंशियल का गैप है, सपोज दिस इज इलेक्ट्रोड ए एंड दिस इज इलेक्ट्रोड बी, सो ए और बी के बीच में जो पोटेंशियल डिफरेंस है वो 12 वोल्ट है। यानी कि 12 जूल एनर्जी स्पेंड हुई होगी एक कूलम चार्ज को लेकर आने में, तब जाके जो पोटेंशियल डिफरेंस आया होगा वो 12 वोल्ट आया होगा। पर इसका मतलब ये नहीं है कि इन दोनों में से कोई 12 होगा। देयर माइट बी पॉसिबिलिटी कि ये 36 हो और ये 24 वोल्ट्स हो, ये विद रिस्पेक्ट टू इंफिनिटी हो सकता है ये 48 हो, ये 36 हो सकता है ये 18 वोल्ट हो सकता है ये 6 वोल्ट्स हो। तो these can be anything with respect to some unknown point, but their difference will always come out to be 12 volt। इसलिए we say that a cell always gives a potential difference and not a potential। सेल के दोनों इलेक्ट्रोड्स यानी दोनों एंड्स के बीच में जो पोटेंशियल जनरेट होता है उसे हम कहते हैं इलेक्ट्रिक पोटेंशियल डिफरेंस, दैट इज टर्मिनल पोटेंशियल डिफरेंस ऑफ अ सेल। ओके, now this is, we are saying, let us suppose the question is define 1 volt potential difference। Now how will you define it? We just need to learn one formula, that is W by Q। So if 1 joule of energy will be needed to carry 1 coulomb of charge, then the potential difference generated between the 2 points of an electric field will be 1 volt। So I am writing this here, if 1 joule of energy is spent in carrying 1 coulomb charge between 2 known points in the presence of electric field, it is called as 1 volt potential difference। अगर आप 1 जूल एनर्जी स्पेंड करते हैं एक कूलम चार्ज को लाने में बिटवीन 2 नोन पॉइंट्स ऑफ एन इलेक्ट्रिक फील्ड ऑफ अ कंडक्टर, तो जो पोटेंशियल डिफरेंस जनरेट होगा वो कितना होगा? 1 वोल्ट। सो वी नीड टू रिमेंबर द फॉर्मूला V इक्वल्स टू W by Q। नाउ the question is calculate the work done in moving a charge of 2 coulombs between 2 points having a potential difference of 12 volts. क्या कह रहा है कि किसी दो पॉइंट्स A से B लाने के बीच में, जिनके बीच में पोटेंशियल डिफरेंस कितना था 12 वोल्ट, तो हमारे पास VAB कितना हो गया 12 वोल्ट्स। चार्ज कितना लाना है हमको 2 कूलम्स और वर्क डन, तो फॉर्मूला इज VAB is equals to work done across AB divided by Q, and this work done across A to B, that is between 2 points, can be calculated as Q into voltage, that is potential difference across AB, and this AB can be written as 2 into your volt was 12 volts, so that becomes 24 joules. So the energy spent in carrying a 2 coulomb charge between 2 points having a potential difference of 12 volts will be equal to 24 joules. Okay? Now, this question can also be asked in another way also. Let us suppose we take an example of the another question, right? A charge of 2 coulomb is brought from infinity to point A by spending 10 joules of energy, and if the same charge is brought from infinity point P, 20 joules of energy is spent. Calculate the potential difference between points A and B. Also calculate the work done if the same charge of 2 coulomb is directly carried from B to A. Okay, now how will I do this? Just notice the question. First it is saying that the charge arises from an infinite point to a known point in electric field, that is point A. Correct? तो पहले किसी infinity से आप कौन से point पे लाए हो? A point पे. Whenever you carry the charge from infinite point to a known point, it is potential and not the potential difference. So that means it will be potential of point A. And potential is given by work done divided by charge. So work done, that is energy spent in point A, was 10 joule divided by 2 coulomb of charge. So your potential becomes 5 joule per coulomb, which can be said as 5 volts. Again from infinity to point B you are saying, so it will be work done divided by charge. Now work done, that is energy spent, is 20 joules divided by same 2 coulomb charge. So now it will be 10 joules per coulomb, which will be 10 volts. Now you have to calculate the potential difference between A and B. Potential difference is the, we can say the difference of the potentials of the two terminal points. So potential difference between B and A will be BB minus BA, because B is at higher potential and A is at lower potential. So the difference will be 10 minus 5, that is 5 volts. 10 volt minus 5 volt, that is 5 volt. Now this question is, we have calculated, and calculate the work done if it is directly carried from B to A. So these both points are known points, and known points you use potential difference. So the formula can be work done in carrying from B to A directly divided by charge, and this potential difference we have calculated as 5 volts. So 5 volts is equals to this work done needs to be calculated divided by 2 coulomb charge, which when cross multiplied gives you 10 volts into coulomb. Volts into coulomb is joule. So work done will be 10 joules. So 10 joules of energy will be required if you carry directly the charge from point B to point A. Is it okay? I hope this is clear to you. Note it down.